Hi, this is Brain. In this session, we'll be discussing about Introduction to Instrumentation and Control. It all starts with a process. In this illustration, you have a process that is starting from the left. It flows to the pump. The pump pushes the liquid into the tank, which fills up the tank, and then when it is required, it goes out of the tank. So we have a process. The process flow is from left to right. And then instrumentation will be introduced to the process. Instrumentation is actually the measuring instrument that will measure the characteristics of the process. One very common characteristic that is measured in a process is the temperature. So a temperature transducer will be installed and a temperature indicator or a temperature gauge, where the operator will actually come to the field and make a record of the temperature gauge. Another very common characteristic that is measured in a process is the flow rate. So there will be a flow transducer and attached to a gauge where the operator can actually keep record of the flow rates. Another very common characteristic that is measured in a tank is the level of the tank. There will be a level transducer attached to a gauge, and the operator can actually make record of the readings of the level of the tank. And one last very common characteristic is the pressure. There will be a pressure transducer attached to a gauge where the operator can come and record the pressure reading of the tank. These are the very common characteristics of a process that is being measured through instrumentation. With the advancement of technology, to increase safety, accuracy, and minimize manpower, the instrumentation will now be connected to a PLC or programmable logic controller. Now let's start with the process again. It's the same process from left to right. Now, instead of just a gauge, the temperature transducer will be attached to a temperature transmitter. This time, the temperature transmitter will convert the physical form of energy into an electrical form in 4 to 20 milliamp current format. The flow transducer will also be attached to a device that will convert the flow into a current, which is 4 to 20 milliamps. Thus, this will now be called the flow transmitter. The level transducer would also be attached to a device which will convert the level into current at a range of 4 to 20 milliamps. Thus, this is now called as a level transmitter. The pressure transducer would also be attached to a device that will convert the pressure into current. Thus, this is now called a pressure transmitter. The purpose of converting this one form of energy into electrical current is for it to be able to be interfaced to our PLC or programmable logic controller. There is our programmable logic controller. In short, this is the PLC. It consists of a CPU. It's just like a computer, and it also consists of input-output. There are two types of IOs: the digital and the analog. Now, what we have here are all inputs. The, the temperature transmitter are actually analog inputs. So this connects to the PLC analog input module. Next will be the contact. This is digital input. It is actually converted into electrical format, which is actually the presence and absence of 24 volts. The flow would also be in current format, which is 4 to 20 milliamps. It goes to the analog input module. The pressure transmitter is also in a 4 to 20 milliamp current range. It's also an analog input format. It goes to the analog input module. And the level is also converted into 4 to 20 milliamp current, electrical current at a range of 4 to 20 milliamp. It also goes to the analog input module. So all of the input transducers, the analog inputs and the digital inputs, are going to the PLC, to their corresponding type of input modules, the analog input module and the digital input module. This time around, we will cover the output signals. The output signals consist of the analog output, which is actually in a 4 to 20 milliamp current configuration, and another type of output is the digital output in 24 volts DC electrical configuration. Now this time around, it's coming from the PLC, and this is actually going to the pump to start and stop the pump. So this is a digital output. It is in red, this is in red. Another output, this is going to open and close the valve from 0 to 100%. So this is actually an analog output in 4 to 20 milliamp current range. And another output, this time it is a valve, which actually is a solenoid valve, which just open and close the valve. So the electrical format is actually 0 and 24 volts. So now we have covered the outputs. If we put it all together, here is your process, here is your instrumentation, the TT, the relay, the FT, the LT, and the PT, and these are your controls. This is the pump, the valve, and another valve. So in this illustration, we have integrated everything, the inputs and the outputs, going to the PLC. Now, there are three layers in this instrumentation and control. The first layer is the instrumentation. As mentioned in the previous page, the instrumentation will actually be connected to the next layer, which is the PLC layer. And the PLC layer will be connected to the higher layer, which is actually the human machine interface layer. This completes the instrumentation and control system. The first layer, the instrumentation layer, the second layer, the PLC layer, and the third layer, the human machine interface.